Plate tectonics and igneous rocks. This is a map of the plate boundaries, and superimposed on top of that map are the main volcanic island arc and subduction zone volcanoes. What's missing here would be the volcanoes along the mid-ocean ridges, but those are also ridges of volcanoes. So we have volcanic activity at mantle plumes, the world's hotspots. We have volcanic activity at subduction zones, where the oceanic crust is going underneath either continental or other older oceanic crust. We also have volcanic activity at mid-ocean ridges, and then within our continents at rift valleys. So let's go over some of that. The volcanic arcs. These are forming when the oceanic crust is subducted. That material has volatiles in it, water, that produce flux melting. That magma then rises up through the overlying crust and comes out as a volcano. There are volcanic island arcs that are big chains of volcanoes, like the Aleutian Island Arc coming off the tail of Alaska, and also pretty much all of the country of Japan. Hotspots, there's a map showing hotspot locations around the world. Hotspots are going to not be at a plate boundary. They are going to either come up through oceanic crust or through continental crust, and that is going to dictate the composition of the magma. If a volcano comes up at a hotspot in oceanic crust, it's going to be mafic. Oceanic crust is basalt. The magma is coming from the mantle. It's going to be a mafic eruption. Remember, mafic eruptions mean that it's going to be a quieter eruption. There's not as much silica tetrahedra. There's going to be a low resistance to flow. Gases escape easily. It's not going to be very explosive. The hotspots in continental crust can be kind of either mafic or felsic or intermediate. There's a mixing. It just depends on what melts, how much partial melting there is, and how much assimilation of the country rock, and how much assimilation of the, what's assimilated. Okay. Continental rifts, these are going to also be possibly intermediate. They might start out with some basaltic flows. It just, again, depends on what is melting. The original melt is going to be from the upper mantle, maybe parts of the lower crust. It's going to be some mafic coming out of there, and then there can be assimilation as that heat transfer occurs and pulling in some felsic material from the continental crust. Example here is the East African Rift Valley. Mid-ocean ridges are decompression melting, is melting the lower crust and the upper mantle. And move my face out of the way. So here is continent, oceanic crust, the mid-ocean ridge, oceanic crust, continent. As the divergent plate boundary is forming, then magma is going to come up into that space, and as it erupts onto the surface, it's going to be a pillow basalt. So pillow basalts are these big bulbous formations of basalt, and then below that is going to be the dikes. Just below that, basaltic dikes, and then below that would be gabbros, and below that would be the ultramafics with like olivines and pyroxenes in them. That's the oceanic crust. So different plate boundaries are going to form different kinds of igneous rocks and have different ways to have either extrusive or intrusive igneous activity.